Hey, this is Don from Padlock Technologies again with another video. This is going to be a continuation of the Inter-AS MPLS L3VPNs. Yesterday we did option A, and today we're going to do option B. If you don't know anything about option A, it's going to be a card up here that is going to point you to option A. Learn that one first before you learn this one, because this one does have a little bit of tricks in it. There are certain things that you need to do. Option A is the simplest version of a Inter-AS MPLS L3 VPN. Everything else adds more trickery to it. And this is what we're going to start with option B. So looks kind of similar to the option A video. The one thing I wanted to show you here is this segmented LSP. So when you do option B, you get introduced to a concept of segmented LSP. If you don't want to know what an LSP is a label switch path. Okay. So when you do MPLS, just normal MPLS, you'll have a label switch path that goes from one PE to another PE. The difference here with option B, though, is you're going to have a segmented LSP, meaning you're going to have an LSP from 7 to 5, and then next to 5 is the ABR. Then the two ABRs, which are 4 and 5, are going to have their own LSP. And then 4 to 1 is going to have an LSP. So this LSP is technically not attached to any of this, right? And BGP is technically doing the labeling here, right, between the ASBRs. Now, the other thing, since we're talking about that, now I want you to know I am doing EIGRP, OSPF, and BGP in this respective customer. So customer A is BGP, customer B is OSPF, and customer C is EIGRP. Now, the difference here is, as you can see, we do not have any sub interfaces here, right? So what we are actually doing is we're activating the VPN before AFI sub AFI on the ASBRs, and they're sharing that VPN v4 table between them, right? So they're sharing the VPN v4 table that has been established between 7, 8, and 5 in ASN 65002, and then 65001. We're sharing that VPN v4 table to 65002. Now, here's the thing. In this version of Inter-AS L3 VPNs, it is very important for your route targets to match. They cannot be different. In option A, doesn't matter because in between the ASBRs, it's a normal IP packet, and you're going to be pushing that label when it gets to oh, well, I don't know what that was. When it gets to its respective ASBRs, it will push a new label on top, which is respective to its service provider network, right? With option B, you do have to worry about the route target values, but since we're sharing the VPN v4 table between the two service providers, the route targets which you import and export must match, right? Now we're not doing any linking in here, so we don't have to worry about importing other values from other customers, but customer to customer, they must match, right? Or you won't import it into your VRF table. The other thing here, as you can see with the BGP, we're using the same ASNs. So because we're doing that, I'm doing an AS override under the address family for CUS A, I believe. I'm doing an AS override, which allows me to send routes with the same AS to each CE, because I'm going to override the CE's AS number with the service provider's AS number. So you'll see 65002 twice, right? In the when you look at the AS path or the AS set. So what's the difference here? Well, there's two key differences here, and I already mentioned it. We're going to activate the VPN v4 table on the ASBR. So let's look at this. Same setup as A from an underlay and BGP perspective, so I won't really be going through that, but I will be talking about the main differences here. Well, it's not BBP, it's BGP. So the main differences here, two things, is we're going to activate the VPN v4 table. Well, technically three things. and we're going to activate it for the ABR. Now we're doing eBGP, obviously, because their ASNs are different. So I created a template here for that. And the special command here, there's two special commands that one gets activated automatically when you do this VPN v4, one you have to put on. This special command right here, which is no BGP default route target filter. So you don't know what that is. It's basically, there's a rule when it comes to MPLS L3 VPNs is basically stating that if you do not have a VRF on the router itself, it will deny the routes. This right here, this command will negate that option, right? So the no default or no BGP default route filter will eliminate that and allow you to have the routes or share the routes with other people, right? So if we actually look at this, as you can see, there's no VRFs on any of my ASBRs, right? But if I show BGP, VPN v4, unicast all, I have routes in my route table, right? Or I have the VPN v4 table here, right? I have routes in my VPN v4 table. If I did not use that BGP, no BGP default route, let me see here, no BGP default route target filter command. If I did not have that there, then my VPN v4 table would be blank. Then I couldn't share the routes in between the ASPRs, right? The second thing is this next hop self. So this is going to the route reflector 3 in ASN 65001. So when you have to use the next hop self command, because when those routes, this is normal BGP now. When eBGP routes go into iBGP, the next hop is not changed, sort of like OSPF E2 routes or E2, E1, external routes, don't matter, right? So you have to do this next hop command so that the ASN knows, hey, you need to go to the ASBR, because if you look at the BGP table, it will have the next hop. If you don't use next hop self, it would have the next hop of the neighbor ASBR, right? And because you don't know how to get there, you'll see it in the route in the BGP table, but because you don't know how to get to the next hop, it will not be a preferred route. It won't get that little carrot, which is the best path to get there. Now, if you know anything about BGP, before it even does best path selection, it has to be able to get to the next hop. If you can't get to the next hop, best path selection is pretty much useless, right? Because I don't know how to get there. So the other thing now, when you activate VPN v4 for the ABRs, what ends up happening is under the interface, right, for option A, under the option B, sorry, under the interface, it will automatically put a command called MPLS BGP forwarding, right? It would automatically do that. So what ends up happening, that this does not do this in iOS XR. You have to manually do this in iOS XR, but in regular iOS, it automatically does the MPLS BGP forwarding. And if we go to G1, which is that interface, this gets turned on automatically in iOS, not in iOS XR. All right. So this allows the segmented LSP to happen. So if we look at our MPLS forwarding table, you will see for certain routes, let me see what we got here. 15. You see how we have these, this right here that says, hey, to go to 10.235.235.15, which is this router here, we have an LSP between, or we have a label switch path, which is my outgoing label is going to be 513. Okay. If you don't have that on there, none of these labels are going to get shared, not going to happen. And basically, traffic will not work. So that is really the key difference between A and B. No VRFs are on the ASPRs. You're sharing the VPN v4 table. You're activating MPLS BGP forwarding. You're disabling the default function of, hey, if you don't have VRFs on your ASPRs, I won't actually share that information and you won't have anything in the VPN v4 table. Now we're going to see that whole segmented LSPs. I'm going to look at, I'll just do the BGP one for now. Let's look in the route table here. If I just do show IP route BGP, I should see 16. So let's ping it here. Source. So we have successful ping. So I'm going from 13 to 16, which is down here. And now we're going to do a trace route to see the label switch path. And what you're going to see is it's going to go from 1 to 2 to 4 to 5 to 6 to 7, but you're not going to see that break like in option A where it became an IP packet and then it got a label pushed on when it came on to the other ASN. You're just going to see a label packet all the way through this time. So that's the label. So we got 415 is the service label and 200. 200 should be popped off, then 415. Then you're going to see 513, I think it was the label that gets swapped. So there we go, 515. And then you're going to see two labels again. And there go the two labels. And then that pops off again. And then that's the VPN label, service label that gets popped off. And now it's a regular IP packet. And then it went down to router 16, which is down here. Now, the reason why it's segmented LSP is because here's the first LSP. This is in ASN 65001. And then here's the segmented LSP right here. All right. So it got to 4. And then it got switched over or to 5. The labels got kind of switched there. It's not technically your normal pop or push pop swap method. And then we get back to the LSP that's in 65002, because as you can see, two labels got put on again. So this is one label, all right, one label. Then it sends that outgoing label. Say if I get something with basically if I get something with 415, I'm going to send it out as 515. And then when it got to router 5, it got this label put onto it. So it got another two labels put on top of it, which is a transport label and the service label. Then when it got to 7, when it got to 7, basically when it got to 6, technically, it popped the 602 label off. That's the PHP process, and then it sent it to 7 with just the VPN service label that get popped off. Then there's the IP packet right there, and you can verify on router 4. Again, if we look at, we'll do show MPLS forwarding table. We'll do label. Let's see. I think it was 415. Did we do details on this? Forwarding table. Let's see what we got. Details, labels. I don't want that. I want labels. And then we want, actually, let me look at the forwarding table for one. See what that label was. Yeah, there it is. Oh, if I get labels 415, there you go. So that was kind of there at the bottom, but as you can see here, now, I wish you could put details on it. Can I get details? There we go. I was about to say. So here's the details. Now this is a layer 2 rewrite down here. So this is a layer 2 rewrite, and this and then it says here's where it's gonna swap the label here. So technically, if I get a label with 415, I'm going to send it out with 515, and then I'm going to send it towards the next hop. Remember, I told you the VPN label has the next hop in it. That's why it's faster in terms of route lookup, because you're not really technically doing a IP lookup. You're doing a label lookup. Here's the next hop. So it's already in the label itself, so it doesn't have to actually, it's a little bit, takes a little bit of the processing out of it. But as you can see, if we look at the trace route, here's the service, the transport label and the service label. Here's that VPN label. I got it as 415. So locally, if I get something as 415, I'm gonna send it out as 515, which I did. And then on the router 5, if I get 515, let's look at here. So MPLS forwarding labels, 515 detail. If I get it as 515, I turn it into 709, which if you look at the path here, we turned it to 709. So it changes the VPN label to 709. And I put a transport label of 602. So that's router 6. Then router 6 pops off 602. 709 goes to 7 and then pops off the VPN label and turns into an IP packet. It kind of just got a brief explanation of how MPLS actually works from a data plane standpoint. Now, I don't have MPLS OAM on, which gives you some more capabilities to look at like control plane or data plane breaks. But this is basically option A. And I mean, option B. I keep saying option A. This is basically option B that has that segmented LSP between the ABRs, and then it gets back to normal MPLS L3VPN logic once it gets to its respective um, SP, our service provider network. And that's option B in a nutshell. So let's review. We are no longer doing VRFs on the ASBRs. We are sharing the VPN v4 table between the ASBRs. So basically, we're activating the AFI, sub AFI, right? We are turning off the default function of, hey, if you don't have a VRF, we are not going to have any routes in the VPN v4 table. The route targets have to be the same so you can import and export routes into the VPN v4 table. You need to have the next hop help command on the ASBRs so that you have the correct next hop in your respective service provider network. And when you activate VPN v4 unicast, it will put MPLS BGP forwarding on the link that is going to the other ABR. So hopefully, if you didn't understand all this, please watch this video back again. Really take your time to understand this. If you're going for your CCIE service provider, this is highly important for you to know because they're probably going to test you on this, right? The other thing is the next video, we're going to talk about option C, which a lot of service providers do not want to do because there is a certain security implication with doing option C, and be on the lookout for that video. If you got any questions, I hope this video was informative. But if you do have any questions, there's going to be a video bumper at the end with an email address where you can send your questions. I don't know everything, but I know a lot. And if I can answer it, I'll tell you, hey, be on the lookout for a video because we're responding to your question. This is Don from Padlock Technologies. Thank you and have a nice day.